everyone, welcome back to Learning with Riad. In our previous lesson, we learned what mechatronics is and why it is used to build smart machines. Okay, and today we are going to try to understand one of the most fundamental thing in mechatronics, which is electric current. So let's start. So right now, I want you to think about and watching you around. You might see like laptops, computer, television, and anything, right? So anything that you can see right now that related to electricity works because of electric current flowing through it. Again, anything that you are seeing works due to electricity. That is happening because of electric current flowing through it. That is this guy, electric current. Okay, let's understand why it's happening, what electric current is, and everything. Okay. Now the question is: have you ever wondered what is flowing and what is actually flowing through the wires? What is flowing through the circuit of it? Is it electricity? Is it energy, or is it something else? Most of you might thinking of it's electricity, which is a sense of way it's right, but more precisely, we engineers we want to say it more precisely, and the reason why electricity is flowing inside of it is basically not electricity, not energy. It's because of electrons. It's because of electrons. So the movement of these electrons is basically what we call electric current. Okay, the movement of electrons, the movement of these electrons inside of a wire. Okay, let's just write it down. Movement of these electrons inside the wire, maybe inside the wire, is what we know as electric current in simple words. Okay, let's now think about what is this electron. We have talked about this electron, but maybe some of you are not familiar with electrons. So basically electrons, to understand electron, you have to understand the broader picture of everything that is made of. Okay, so suppose you have your phone or laptop in your hand that you are watching this video from. This thing is made of particles or maybe matters, and in simple word, those things are made of atoms, and atoms is made of three particles: electron, which is rounding around, which is negatively charged. Then we have a proton, then we have a neutron. Proton is positively charged and neutron is neutral, nothing. So in this particular class, we mainly concerned about this electron. Because this is what's happening. So this is the reason why we're getting electricity and everything, basically everything. Okay, let's now think about another thing, is how this electrons is moving around the wire. So you know that inside a wire we have conductor. We have a conductor, right? We have a maybe metal, or must be a metal or something that conducts electricity. So what does electricity conduction mean is you have electrons right here, you have electrons that can flow through this metal bar or through this conductor. That's why we are saying it conductor, and that what is making our electric current. Okay, to this lecture. Okay, so imagine that you have a classroom. Okay, you have a classroom right here. Imagine that this is a classroom, and the door is closed and class is going on. So after some minute, the class is over and teacher told you to go. So what happens when the door is open? We have a door right here. What's gonna happen is the student is gonna come through the door to outside because the school is over. So that is when the student is coming from the door. That what we call this flow of students. Okay, so now they're going out, and this is called the flow of students. Because suppose you had thousands of students, and you have a door, and on that door the students are going, right? So you can measure like 10 students is going per 1 minute, 100 students are going. So this is a flow of a student that is going through the door. Exactly like that. Electrons are exactly like that. So when you have a stack of electrons in one side, like the students, and your door is basically stopped, like your door was closed, so the electrons and the students are inside of it, and when we open that, like the students, the electrons will move to the other side. So right now, just understand the electrons will move to the other side. So suppose you have a battery right here, you have a positive terminal right here, you have a negative terminal right here. You have been seeing this for years. In battery, you'll see that there's a positive sign at the top, there's a negative sign at the bottom. So what this signs actually mean is you have a lot of electrons. You have a lot of electrons on this side, and you have a really few electrons, or maybe as near zero electrons on this side. So what this electrons is gonna try to do is they want to go on this side, because as we have talked about this crowd, they want to go this side to flow electric current. Okay, so what this happens is they want to go on this side. So when you have suppose you have a wire right here, and the wire is they can actually go, so the electrons can go this side, and they can like balance each other out. So that's what electric current is basically. Let's try to see another example. So right here you have water, right? You have a lot of water inside here, but let's try to draw something like this, and you have another, like maybe another tank here. So imagine that what's happening when, so you have a tap right here, which is right now closed, tap. So when you close the tap, what's happening here? All the water are here, they're stuck here, water. But when as soon as you open the tap, the water is gonna fall down, right? It's basic. So they'll try to fall down as much as possible, and they'll like fill up this part, the whole area here. Yeah, electrons works exactly like that. They also wants to come here, right? Like the water analogy, electrons also wants to go from like this. They also wants to go from this side to this side. So that's what makes the electron from going a lot of electrons to lesser electrons. Okay, let's right now another example you can think of is when, so you have a battery right here, which is a positive and negative, and what's happening here? So we have, as we have talked about, we have a lot of electrons right here, electrons, and they wants to go this side from this side. Okay, but the thing is, this was open, so you can't like go. As it's open, it's not a complete circuit, so you can't actually go. So when we tag them in here, when you like add them in, when you close the circuit, now the electrons can go from this side to this side, from negative to positive. So that is what actually is happening right here. But in conventional current, actually how we like to draw is from positive to negative. So everywhere in the book we have been doing it for years, so that's why we still do it. But in real life, the electrons is actually moving from negative to positive side. But in books and every day for calculation and everything, we actually draw it like from positive to negative, like this side. We'll draw it from like this side. Okay, just have to keep in mind that what is electric current right now. So the flow, we can simply say that the flow of electric charge through a conductor. So we already talked about a conductor. Suppose it was a conductor, we already talked about that. So simply the flow of electric charge through a current. And right now, okay, so many of us might not be familiar with charge. So the charge is represented represent as letter Q. And what is this charge is basically is, imagine you have imagine that you have a water pump right here, water tank right here, and you had 10 liters of water. 10 liters of water. Okay, liter. Okay, so when you measure the water, right, how do you measure it? Do you measure like 1 molecule, 2 molecule, 3 molecule, 4 molecule, 5 molecule? No, right? You measure it with liters, like maybe you measure a lot of molecules and you measure it as a liter or maybe ounce. Exactly same like that. The electrons that is moving, right? We don't. There should be like billions of electrons moving per second, right? And that thing we measure the total of electric charge. So we don't count every electron, but we say them as charge, and which is we represent at Q. So now I think it's clear why we say Q as electric charge. We don't measure every electron, so the amount of the total amount of electric charge, we call it Q. Okay, and the unit of Q is the unit of Q is, let's try a different color, coulomb. Okay, and represent it as capital letter C. Okay, yeah, so simply says right now is I, which is electric current, is represented as the amount of charge flowing over the time. Okay, so suppose you have here we have only 1 amp, so in 1 amp means 1 coulomb of charge here, so charge per second. So suppose you have 8 coulombs of charge. You can pause and think of if you have 8 coulombs of charge flowing through a wire in 2 seconds. What is gonna be the electric current? So the electric current will be Q. You can pause and say, right, Q divided by T, which is 8 divided by 2, which is 4 amps. The unit of electric current is amperes or amps, whatever you would like to say. Yeah, and that's basically all. So we have learned about what electric current is, how it works, what this guy charge is, how we measure it with coulomb, and time with T, and then electric current. So right now you should have the basic understanding of what is electric current. Another very important thing that I want to talk about is this electric flow, right? Conventional current. So electric flow in regular life, we basically use it like this, from going from positive to negative. But in real life, actually electron goes from negative to positive. Okay, so in your books and everywhere you will try to use this conventional current method, which is going from positive to negative, but actually electrons goes from negative to positive. And yeah, thank you for that's all.